The group of problems people found next most difficult, and these problems are in fact challenging to some extent, concern normal curve and interpretation of the normal curve. So let's look at that. Now, whenever you see something that's going to involve the normal curve, before you do anything else, before you even read what the problem is asking, as soon as you recognize that you're going to need to interpret something on the normal curve, you draw this picture. Now I'm going to draw it for you. The first thing you do is you simply draw the bell-shaped curve, and you divide that at 60% of the middle height and at 1/7 of the middle height, approximately. You're just representing things, and it's not necessary to be really meticulous about it. And you label the z-axis, -2, -1, 0, 1, 2. Now, on the problems that you have in the test, if it's relevant, I'm going to also give you information that you should automatically know. I shouldn't have to give it to you, but some people have trouble remembering numbers, and I don't really mind giving it to you. The fact that if we split between z equals 0 and 1, we split this at 1/2 and split here at 1.5, then %19 of the distribution is between 0 and z equals 1/2. 34% is between 0 and 1, and that's one you certainly should know. 43% is between 0 and 1.5. 48% between 0 and 2. And the numbers are the same on the other side. And if necessary, if the question involves numbers below the mean, you're going to want to also label the same numbers on the other side. Okay? So it should take you no more than a minute, and you should be able to do this. And I really recommend that between now and the time you take this test, every day you take a minute and write this out from memory. If your memory messes up, go back, review it, give yourself a few minutes, put all your notes away, and write it out again. You need this, and you need this picture. And another thing you should probably add to the picture is that you have 50% to the right of 0. Just remind yourself of that. You know it, and you're probably going to use it when it's important, but it really helps if you actually write it out. Okay? So this is the picture, and the information given on the first of the problems includes these percents in case you've forgotten them, but you really shouldn't need me to tell you what those. You really should be able to just ignore that and write this down. But the numbers will be there if you need it. Again, I don't mind giving you those numbers. That's perfectly okay. Well, so we draw the same picture for the first problem, and the first problem asks what percent of the distribution what percent of the outcomes on a distribution will be greater than z equals 2? Well, we write down our percents here. So we've got a picture, and we also write down the 50%. And then we ask, well, greater than 2. That's from here on out. What's that percent? Well, from here to here is 50%. From here to here is 48%. That leaves 2% from here to here. And that should be really obvious to you. If it isn't, please send me a question, come by and ask me. Okay, the next question tells us that the mean time in a track meet for a 100-yard dash is 10.224 seconds, standard deviation 0.73 seconds. Assuming that this is normally distributed, then the question is going to ask you ultimately, what time do you have to beat to be in the top 8? Now, I think you're going to be pretty close to world record if this is really normally distributed. I'll comment on that just a little more at the end. We didn't get to that comment in class, so I'll kind of add it probably in another video. Okay, well, first thing we do, we've got a mean and a standard deviation. What are we going to do? We're going to assume it's normally distributed. We're going to draw our normal curve. We're going to label our 19, 34, 43, 48% and our 50% just to be sure, and understand that we have the same percents on the other side. Then we're going to label our z values, -2, -1, etc., and that's all automatic. It should take you no more than a minute to do that, and you can probably do it in 20 or 30 seconds if you practice it and do it every day between now and the test, as I have recommended. Okay, and then you label your x values. Now your x values are the values of the times, the mean and standard deviation being 0.73. The z equals 0 time is your mean. That's 10.224 seconds. Okay, then z equals 1. What does 1 mean? 1 means 1 standard deviation more than the mean. Well, the mean is this, the standard deviation is this. 1 standard deviation more than the mean is the mean, 10.224, plus 0.73, the standard deviation. And that's 10.954. Now, the 0.73 might really be 0.730. We might have 3 significant figures here. Probably we don't, so this last figure here is not really significant, but we're not going to worry about that. We're going to take the numbers just at face value without thinking too much about them for this example, although in reality you would probably ask, is there really a 0 on this? Is a 0 really significant so that it makes sense to add the 0 to the 4 here? Okay, well, then we do z equals 2. Well, that's going to correspond to a time of 11.664 seconds, if I've done my arithmetic correctly. I did it in my head. Don't trust me. Check me out. Then 0.73 seconds less, I think is going to get us at 9.494, and 0.73 seconds less than that is going to get us 8.764. And of course, Usain Bolt's world record is right in here somewhere. So we really aren't going to have that many of our participants breaking the world record, much less by 3 or 4 tenths of a second. Okay. Now, the way the problem was stated on the practice test that you have, I'm going to fix that, but the way it was stated on the practice test that you have, excuse me, the question didn't tell you how many participants there were, but it asked you what time do you have to be in the top 8. You couldn't answer that question with the information I gave you. Now, as I say, when you have the test, you will have that information. Double check the test before I print it and take it to the testing center. But in that situation, just so you know, there are 2 things you can do. One thing is you just draw this picture and you get all the numbers here and you get your percents in there, and then you indicate I can't do any more and I'll give you full credit if that isn't given. Now, I went ahead and said, okay, well, let's say there were 80 participants, that number that's given. And now you're responsible for doing the whole thing. So what we want to say is, okay, how many of the times are in the top 8? Now, the top 8 would be the 8 fastest times that would be on this side. If you happen to get it on the wrong side, you'd still get the right answer. And I'd probably overlook the error, depending on the situation. Okay, well, how do you get it? What's the time of the top 8? Well, if there are 80 participants, the top 8 will be top 10%. Top 8's your top 10%, and that should be pretty obvious, but you just divide 8 by 80, multiply by 100, you get 10%. It should be very obvious to you that 8 is 10% of 80, but if you have like 7, then you have to divide the 7 by the 80, get the percent. One way or another, you get the percent. This is a percent of this. The top 8, it would be whatever percent of your participants. And then you say, okay, well, we're looking for the 10% fastest times. That would be the 10% between whatever your time is and here. Now, where's your top 10% going to occur? Why did I put it here? Well, 34% of your distribution is here, which would leave 16% from here to here. 43% of your distribution is here, which would leave 7% on this side. We want to leave 10% on this side, so it's going to be somewhere between here and here. Another way to look at it is if we have our top 10% here, then we got to have 40% here. And if 40% is here, well, that's between 34% and 43%. Probably closer to 43%, but remember that the height of the curve is going down, and we're looking at the area. Okay, we want 10% of the area of the curve, so it's not completely clear where to put that. Now, if you give us this, if you say, well, you're going to have 40% between here and here, and you're going to need 10% between here and here, and it looks like it's here, and if you get this number at a reasonable point between 34 and 43, and have this labeling, you're going to get 7 points out of 10. You're going to get 70% credit on the problem. And this is a fairly one of the more challenging problems. So if you figure that this is your top 10% and put your 10% here, your 40% here in a reasonable place, as I say, that's 70% on the problem. 7 points out of 10. It's pretty good. To get the full credit, you're going to have to go to the Z table and look up the appropriate number. What's the appropriate number? Well, the Z table that you're going to be given tells you the percent of people between 0 and between the mean and whatever percent you're looking for, whatever value you're looking for. So that would be the 40%. You look up and see what Z value corresponds to 40%, and then you see what time corresponds to that. So I'm going to write a couple of things down just to complete this. Well, we can get the exact value of Z from the Z table. We look up the 40%, the Z value for which you have 40% of the area between the middle and your given Z value, and you get something around Z equals negative 1.6. And don't hold me too closely to that. Look it up yourself. It might be 1.7, might be 1.5. Okay. Well, it's not 1.5. Oh, gee, I've got a bad value there. Hang on a second. Okay, I had to make a correction. I actually made a mistake there. I was estimating between negative 1 and 2 as if the 2 was here. Here's negative 1, here's negative 1.5, and the 40% lies in between there. And I'm saying that to the nearest tenth, that should be about Z equals negative 1.3, not the negative 1.6 I had there a minute ago. So, from the Z table, 40% of the area occurs for Z equals negative 1.3. 40% between 0 and that value of Z. So Z equals negative 1.3 though, and if you get that, if you get that from the table and show me that, you're up at least another point. You're up to 8 points. But what I really want to see for full credit is I want you to tell me what time needs to be beat. And so far you don't have a time. What time goes here? Well, it's going to be between 9.4 and 9.49 and 8.76 seconds. But let's calculate it. It's going to be Z equals negative 1.3 means the mean minus 1.3 standard deviations. So that's going to be 10.224 seconds minus 1.3 times 0.73 seconds. And that's going to be pretty close to, well, let's see, 1.3 times 70, or times 0.7 would be 0.91, be about 0.94. It's going to be around 9.3 seconds. Of course, you can refine these calculations. You can get a more accurate value of Z by looking at the table. I do recommend that you do that. 9.3 seconds is pushing the world record. I don't think you're going to have 8 people out of 80 in any group pushing the world record that hard, but that's because the distribution probably wouldn't really be a normal distribution. It'd probably be a slightly skewed normal distribution. I'll talk about that a little bit just briefly in the next video clip. It's not something you're responsible for, but it does give you a little more perspective on the meaning of the curve and the application of statistics in the real world.